Hello and welcome to video lesson topic 11.2. It is surface areas of prisms and cylinders. Now 11.4 is going to be one of our upcoming topics, and it's kind of combined with this if we were in class, but for today I'm just going to do one lesson at a time. Our learning objective is I am learning to find and we're going to abbreviate here, surface areas of prisms and cylinders. And for a prism, let's start with cylinder, okay? Cylinder's like a can. A prism is like a can, but it's not made of circular bases. So a prism is a polyhedron, so it's three-dimensional. Polyhedron means that shapes are making up the sides, creating a three-dimensional object with exactly two congruent parallel faces. So an example would be, say for instance, I had this. Okay, this would be an example of a prism, a rectangular prism. Bases are the two congruent faces. It could also be something like a triangular prism. So say for instance, this is your three-dimensional object. This is a triangular prism because the bases are triangles. Now the lateral faces are not bases. So simply put, any face and the sides are called bases. Any face that is not a base is called a lateral face. Now your altitude is, if it makes a right angle, it would be the perpendicular distance between two bases. And in a picture, it would be what's known as the height. Now, I know that this looks weird because the height isn't how tall it is, but you can orient this however you want. If you want to stand it up vertical, that's fine. But your altitude is also known as the height. It is the distance between bases. In other words, the length of the altitude. The lateral area is the sum of area of non-base sides. And the surface area is the sum of the area of all sides. And you're like, what does that mean? Well, there's a formula for it. Okay, your lateral area, the formula is the perimeter of the base times the height or altitude. And the surface area, what that would mean was you'd have these three rectangles as part of the triangular prism. That would be the lateral area. The surface area means you add on the area of the two bases. So that would be the perimeter. So P equals perimeter of one base. And H is the height. So the perimeter times the height plus 2 times the area of the base. B is equal to area of one base. I know this is kind of confusing, but we will have a few examples here to help you out. A right prism, I'm not going to get too far into it. It's basically like, a good looking prism. Like these are right prisms. Oblique prism looks like kind of like a prism that you stepped on. So for instance, this would be a right prism. It's a nice looking prism. And then an oblique prism would be something at more of an angle. So for instance, if I had like this rectangular prism and it looks like somebody walked by and kicked it. Right, so something more like this where your altitude is going to be this distance. Right? They're funny looking is the best way I can put it. The right prisms are a good looking prism. The lateral area and the surface area is what we're going to focus on most, which is going to be filling in the formula. You have the exact same thing. So for a cylinder, so if I were to change one of these, instead of the bases being a triangle or rectangle or pentagon or whatever it is, if I just switch that to a circle, that's what a cylinder is. It's basically a prism, but the bases are circles. So I'm just going to leave that there. I don't want to make this too complicated. It's literally the exact same thing. Right cylinder and oblique cylinder, you know, this is a right cylinder. And then an oblique cylinder would be something kind of offset where it looks like somebody walked by and kicked it. It's like a can that you dropped or something. And the altitude now is going to be this distance. We're going to talk about volume in 11.4, so you can just ignore these for now. The formula for the surface area of a prism, or the surface area of a cylinder rather, because we already have this. I'll rewrite it here, but lateral area, perimeter times height, surface area, perimeter times height plus 2 times the area of a base. The lateral area for a cylinder, it's kind of weird. If you were to take a can, like a can of soup from your cabinet, and you took the label off of it, and you unrolled it, what you have is a rectangle. Right? You unroll that label. If we were in class, I'd literally show you that. So this is going to be a rectangle's area. And it's going to look weird because the length of the rectangle is actually the circumference of the circle. That's what makes it so weird. So perimeter times diameter, or not perimeter, but circumference would be pi times d times the height. I know it's really confusing, but if you unrolled this, you have a rectangle, and how long that rectangle is however long around the circle is known as the circumference or the perimeter of a circle. And then the height would be literally the height of the prism. I think it'll make more sense once we actually do an example. And then the surface area would mean you would add on the area of the two bases. In this case, the bases are circles, so pi r squared would be the correct formula. The reason I put B here is because a prism could be, it could have any shaped base, right? Could be a rectangle, could be a pentagon, hexagon, who knows? So whatever the area for that shape is what you would have to use in order to find the base. In a cylinder, it's always a circle. Like a cylinder does not exist that doesn't have a base that's a circle. So that's why we can just keep it, instead of putting capital B, we can put pi r squared. And then again, we'll save the volume. So we have some examples. And I'm going to try to keep this simple. I want you guys to fill in the formulas pretty much. So example 1 says, use the formulas for lateral area and surface area of a prism and show your answers to the nearest whole number. We're going to do part A and part B. Part A, to find the lateral area, that would be the perimeter of the base times the height. Now the special thing about a rectangular prism is it actually has multiple pairs of congruent sides, meaning that we could pick the top and bottom as bases, the left and right as bases, the front and back as bases. But for part B, in contrast, it only has 2 sides that are congruent, that are parallel, and it's these 2 triangles. So you'll have to use the 2 triangles as bases. Now, if I say, for instance, that my bases are the left and right side on part A, the perimeter would be 4 plus 3, or no, that's a 5. 4 plus 5 plus 4 plus 5. So the perimeter would be 10, 14, 15, 16, 17, 18. And the height would be the distance between the 2 bases, which is 10, giving us a lateral area of 180 feet squared. Now with that in mind, the surface area would be perimeter times height plus the area of the 2 bases. So I could refill that in, or I could put my answer that I already have there, 180 plus 2 times the area of this base. Well, a rectangle is length by width, or base times height, so that'd be 4 times 5, or 20. So if you simplified, this is 180 plus 2 times 20, which is 40, which gives us 220 feet squared for the total on part A. Now part B, you have triangles as your two bases. So the area or the perimeter for the triangle, and this is a 3 here, so this is 3, 4, 5. The perimeter would be 3 plus 4, which is 7, plus 5, which gives me 12. And the height would be the distance between the two bases, aka the altitude. In this case, the height is 8. So 12 times 8 would be 96 inches squared. Now the surface area, you'd have to add on to the 96 2 times the area of the base. Now this base is a triangle, which has an area of 1/2 3 times 4. And the area of a triangle is always 1/2 base times height for this right triangle. So 1/2 times 3 times 4 gives me 12 times 6. So 12, 96 plus 12, which is 108 inches squared. For example 2, you're going to repeat that exact same process, except you're going to use the formulas for cylinders because all these are cylinders. So again, we'll do example 2, part A and B. Oh, it just says find the surface area. Leave in terms of pi, so don't put pi in the calculator. So the surface area is the circumference, pi times diameter, or 2 pi r, times the height, plus the area of the two bases. So for part A, we'll do pi times a diameter. Well, the radius is 2, so the diameter, if we wanted to double it, we get 4. And then the height would be the distance or altitude between the two bases, in this case 8, plus 2 times pi r squared, so 2 squared. And then you'd simplify. Remember, you don't want to put pi in the calculator, so 4 times 8 is 32 pi, plus 2 squared is 4, times 2 is 8 pi, and then 32 pi's plus 40 pi's, or plus 8 pi's gives us 40 pi's. Excuse me. And then part B, you're going to repeat that process. Pi times the diameter. This time they gave us the diameter, and the height is 4, plus 2 times pi. If the diameter is 3, the radius would be half of that, so 1.5 squared. And then you'd simplify. I'm going to use a calculator this time since we got a decimal. Don't put pi in the calculator, it goes in the answer. So we would put in 3 times 4 plus 2 times 1.5 squared, giving us 16.5 pi. And this is centimeters squared, this was centimeters squared.